Dear student, now we are looking at the application of TIR, total internal reflection. This is one of the very important application. Finding maximum radius of circle to view outside world. Finding maximum radius of circle to view outside world. Finding maximum radius of circle to view outside world by fish from denser medium. Dear student, here is a fish located at a distance h. From this medium interface. Here refract index is mu. Then the maximum angle in which the fish can see the outside world, this is theta c, this is critical angle, because light ray will move here. And in a similar way, on the left side also, this will be the same case. This will also be critical angle, okay? So this is the radius of the circle, okay? If this is theta c, this is also theta c, this is theta c, this is theta c, okay? So we can easily find maximum radius of circle. We know sin theta c is how much? This is 1 upon mu. This is equation 1. And now, dear student, what is tan theta c? Tan theta c is r upon h. So r is what? H tan theta c. So h upon tan theta c is r upon h, okay? Sin theta c is 1 upon mu. So r equal to h tan theta c. So maximum radius you can find from here h tan theta c. You can substitute the value of tan theta c. How? Because sin theta c is 1 upon mu. What is sin theta c? Perpendicular hypotenuse. This base will become equal to mu square minus 1. So tan theta c will be 1 upon mu square minus 1. So dear student, this is the maximum radius of the circle to view outside world. If somebody asks maximum area, this is pi r square. Somebody asks maximum cone angle, this is 2 theta c, okay? So this is the case to view outside world, okay? Now let's see very important phenomenon that is called prism. Now we will see prism combination and dispersion and spectrum of light, okay? In case of prism, it is made up of normally transparent homogeneous medium where two refracting surfaces remains inclined at some angle, okay? That angle is called a prism angle. Now one by one, let's see the things. Suppose, dear student, this is a prism. This is the cross section of the prism ABC, where BC is the base and A is the prism angle. Here PQ is the light ray incident, QR is refracted ray, and then RS is final refracted ray. Dear student, now let's see, this is normal. to this refracting surface AB, this is normal to this refracting surface AC, and this is common intersection point. This NN dash is normal to AB and NN double dash is normal to AC, okay? If this angle is angle of incidence, this is internal angle of refraction R1, this is R2. Since NN dash is normal to AB, so this angle will be how much? This angle will be 90 minus R1. Again, NN double dash is normal to AC, this angle is R2, so this is how much? This is 90 minus R2. Dear student, in the triangle AQR, sum of the three angles is 180 degrees. So we get A plus 90 minus R1 plus 90 minus R2 equal to 180. So finally we get R1 plus R2 equal to A. This is one equation, okay? And now if we apply Snell's law here at point Q and R, we can get another equation. How? Let's see here. If we apply Snell's law at point Q, what we are getting here is air. Let us assume refractive index of prism metal is mu. So 1 into sin I equal to mu into sin R1. So sin I upon sin R1 equal to mu. In a very similar way, if we apply Snell's law at point R, we get mu into sin R2 equal to 1 into sin E. So we get sin E upon sin R2 equal to mu. Now, dear student, if we are interested in calculating the equation of deviation, that also we can calculate here. Let's see again deviation. If this was the cross section of the prism, initially this was the light ray. Had this prism could have not been here, this light ray could have been moving like this, but this light ray moved like this, okay? Since this angle was I and this angle is given R1, okay? Dear student, since this angle will be I, so this is the angle of deviation, delta 1 in clockwise direction. This is equal to how much? I minus R1, okay? Now let's see again. This light ray is moving here. This is angle of emergence E, okay? If we extend the prism like this, if this angle is R2, this angle is again R2. So this angle of deviation delta 2 is E minus R2. This is also clockwise. So total deviation is how much? Dear student, total deviation is delta 1 plus delta 2. This is I minus R1 plus E minus R2. This is equal to I plus E minus A. This is the relation between angle of deviation and angle of incidence, okay? Now, dear student, let's see some very important relations. When we draw experimental curve between angle of deviation and angle of incidence, the curve comes like this. This curve is not parabolic, okay? This is asymmetrical. At particular angle of incidence, when angle of incidence remains equal to angle of emergence, prism remains in minimum deviation position. And there are two angle of incidence. There are two angle of incidence when angle of deviation is same. Okay. And these are maximum angle of deviation. This we will see later. This is called grazing emergence. and this is called grazing incidence. Now dear student, let's see minimum deviation condition. Condition for minimum deviation. In case of minimum deviation, whenever you want to find minimum deviation in case of any prism, okay, the most important thing that light ray must be symmetrical, means angle of incidence must be equal to angle of emergence. And when angle of incidence remains equal to angle of emergence, what remains? This light ray remains parallel to the base, means R1 remains equal to R2. So delta remains equal to delta minimum. See here, when I equal to E, dear student, delta is delta minimum. In this situation, I plus E equal to A plus delta. So we will write 2I equal to A plus delta minimum. So that will give us I equal to A plus delta minimum upon 2. And what is equation of R? Let R1 equal to R2 equal to R. So therefore 2R equal to A. So R equal to A by 2. So dear student, when we applied strength to here, we found 1 into sin I equal to mu into sin R1. Okay, that will give us mu equal to sin A plus delta minimum upon 2 divided by sin A by 2. This is the refractive index when prism is kept in air. Okay, if prism is kept in medium, then write mu prism with respect to medium. For a small angled prism, means prism angle less than equal to 10 degree, sin theta equal to theta. So mu will become approximately A plus delta minimum, 2 will get cancelled, divide by A. So dear student, delta minimum will come equal to mu minus 1 into A. For a small angle prism, this minimum deviation is independent to angle of incidence. Okay, this angle of deviation is independent to angle of incidence. Okay, now dear student, let's see some more important cases for this prism. See what happens when this situation comes. This is called grazing emergence. This situation will come when R2 will be equal to theta C. In this case, dear student, I will become equal to I limiting. Okay, now let's calculate what is maximum deviation in this case. If the prism could have not been here, this is the maximum deviation. This is prism angle. This is maximum deviation. Okay. And this is I limiting, and this is 90 minus I limiting. So dear student, when R2 equal to theta C, since R1 equal to A minus theta C, this equation is very important. Sin R1 equal to sin A minus theta C. Just expand the relation, sin A cos theta C minus cos A sin theta C. This is sin R1. 1 into sin I equal to mu into sin R1. So sin R1 is sin I upon mu. Dear student, if you substitute the value of sin theta C, that is equal to 1 upon mu, and cos theta c, sin theta c equal to 1 upon mu, means cos theta c equal to what? Under root mu square minus 1 upon mu. If you substitute all these value, this I limiting will be equal to sin inverse under root mu square minus 1 sin A minus cos A. Okay, this is the limiting angle of incidence. Okay, this is the limiting angle of incidence. Now look at the very important situations. This is the situation when I remains equal to I limiting. And this is the situation when I remains greater than I limiting. And this is the situation when I remains less than I limiting. Okay, I am telling you about very important, one more important thing. When R1 equal to R2, both are equal to critical angle, then this is the situation. So dear student, if in any case, if A becomes greater than 2 theta C, once the light ray enters in the prism, it will never come out of the prism. Okay, if A greater than 2 theta C, if light ray enters in the prism, the light ray will never come out. Light ray will not come out of prism. Okay, this was the simple things about the prism. Okay, in the next lecture we will see about the prism combination. Okay, thank you.